Hey folks, I'm excited to be doing our first ML system design video on the channel. You all have been asking for this in the comments, in our Q&As, and then also in our email. So I'm glad to be finally getting to this. ML system design is very different from traditional SWE system design, and there's a lot to talk about. So I wanted to use this first video as a chance both to give you a framework for thinking about how to navigate ML system design interviews, but also going into a really rich problem around harmful content or content moderation. A little bit about me, if you haven't seen our channel before, I am Stefan. I'm one of the co-founders. You'll see my partner, Evan, frequently on this channel. And I've conducted in my career more than 2,000 interviews at companies like Amazon and Meta. At Meta, I was a senior manager for applied ML teams. Specifically, my org was called Dangerous Content. So you can see that there's a lot of overlap with some of my experience with this interview. But I want to cover the things that interviewers are looking for, which is not necessarily kind of a specialist deep dive into this problem. So we're hoping to use this session to give you an idea about how you should think about interviews on a general basis. Let's go ahead and dive in. ML design interviews are a little bit of a wild card. The industry has not converged on a central definition of what an ML engineer looks like. And as a result, each company is building their interview process around a slightly different role description. There's kind of two axes that we generally see in terms of role variants that are worth talking about. The first is how much research focus does the role have? You can either be pumping papers or producing business results or something in between. The next piece is how much of the traditional infra or software specific aspects of the role are important. So on one hand, you might have a research scientist at Amazon who is mostly focused on modeling and isn't in the nitty-gritty of the engineering, which software development engineers are doing. On the other hand, ML engineers at Meta are kind of operating at a full stack. They are pulling in recent research to build models and deploy them to production. So what you need to do before your interview is get an idea of what the role that you're interviewing for looks like. And then that will give you some expectations around how the interview is structured. In this diagram, I've kind of laid out these ideas. And in the middle here is the applied ML system design, which is basically what we're going to be doing. But note that if there was more emphasis on infrastructure, if you were interviewing for one of the core platform teams, you might have an ML infra design interview. If you are interviewing for a more research-centric role, you'll probably have a research-oriented interview, which really won't look the same as an applied interview. And we'll go a lot deeper on some aspects that we won't cover here. So get an idea for what your interview looks like. We'll have some guidance on that on the website. Now, inside an applied ML system design interview, there's a lot to cover. The thrust of this interview is trying to figure out whether you'll be productive as an engineer joining the team. And the ML engineer role covers a whole bunch of different things, from pulling data and engineering features, modeling, building inference pipelines, evaluating models, and iterating on the whole thing. In the interview itself, you're going to cover all of these details, and it's really easy to get lost in any one particular aspect and not be able to cover all of the things that are going to be important. So we recommend that you use a framework to drive the back end of your interview. Now, your interviewer is going to give you hints. They're going to ask you things along the way. You should definitely follow their lead. They're going to be the authority through your interview. But for those interviews where they give you an ambiguous question and they want you to work through it, this will be helpful for you. And we've got 6 different steps in the ML system design interview. The first step, and this is not one that you should neglect, and I'll talk about more in a second about why, is the problem framing. This is where you're going to figure out what problem am I solving, clarify requirements, set up goals, so on and so forth. The next part is a high-level design. This isn't the high-level design of a SWE interview. Oftentimes, you're not actually going into databases and different intricacies about query patterns. The point here is just to have a block diagram that you can refer back to so that your interview knows what you're talking about as you go into greater detail in later sections of the interview. The next piece is the data and features discussion. This is important for you to be able to talk about what data is useful. Oftentimes, better data beats better models, so make sure that you cover it. and then talk about the logistics of how you would engineer and represent these as features in your model. A lot to discuss there. Next, you'll talk about modeling. This is where you're going to make a choice about what models to employ. You'll also talk about model architecture and some of the trade-offs. A lot of rich discussion here. With your model in place, you're going to want to talk about how you would actually bring it through to production. What does inference look like in this setting? What are the challenges and how will you solve them around evaluation? And finally, we want to leave room for deep dives at the end. We'll use these in two ways. One is that going through the interview, you're going to find all sorts of interesting things to talk about, and you don't have time to talk about all of them. So one strategy for you is to make a note of those things and come back to them in the deep dives. So that way you can make sure you make your way through the problem and give depth on some of them. Also, in the deep dive section, this is where your interviewer is probably going to ask you more detailed questions, but you kind of have to set the stage for them so that they can get into those interesting questions. Especially for more senior candidates, if your interviewer is driving, they're getting this impression that maybe you haven't built these systems before, which is exactly the opposite of the impression that you want to be making. So that's why we want to cover all of these sections. All right, with that out of the way, let's talk about harmful content. We're going to cover a lot of ground here. And so if you want to look at the written write-up, I'll include a link in the description. It also will get you in the middle of our ML system design content on Hello Interview. We've got other problem breakdowns, deep dives, a lot of other content we're hoping will be useful for you. And we're hoping to make the majority of it free. But we will be adding premium content as things move forward if you want to go into greater detail about more advanced topics. Most interviews are going to start with an ambiguous problem statement. Your interviewer might go, hey, design a system for detecting harmful content on Facebook. And right at the outset, many candidates are thinking, hey, it sounds like they're asking me to design a classifier. That's not wrong, but it's really important that we spend some time digesting this problem, looking for potential avenues and ways that we can design a solution that satisfy the requirements, but may not look like a classification problem, and then setting up the constraints for our solution for later. We recommend three things when you're framing out a problem. The first thing is you have an opportunity to clarify the problem, find constraints, figure out how the product operates, identify the users of the system and what they're actually doing. All of these things are going to give you detail that's going to be important for building out your system as you go along. The next thing that we're going to do is establish a business objective. This is easily the place where senior and staff level engineers will differentiate themselves because many ML systems have business objectives that aren't perfectly aligned with their ML objectives. And the final thing is we want to distill that business objective down into something that we can build machine learning systems around. For harmful content, this is pretty simple. We're building a classification system. You were right if you made that assumption. But for other systems, you might have multiple objectives, and there's a lot more to talk about. So let's go through these steps for harmful content, and then we'll keep moving into our high-level design. To clarify the problem, we're going to do a bunch of back and forth questions with our interviewer. And so some examples of questions are things like, do we need to include video or just images and text? And our interviewer might say, hey, you're off the hook. We don't have to deal with video here. We also want to understand a bit about the data. So we might ask our interviewer, what kind of content do we want to detect? Is it just like nudity and violence, more severe things? In this case, they're not going to let us off the hook. They're going to tell us, go ahead and detect everything. An important consideration for us is like, who are the actors in the system and what are the consequences of the actions that they might take? So one question would be, what happens if we find harmful content? Do we remove it? Do we demote it? Do we ban users? And then we want to understand those consequences. What happens if we have too many false positives or false negatives? In this case, our interviewer is going to let us in on a secret for harmful content that there's a trade-off here. Like all systems, there is really no right answer. But for Facebook in particular, they're going to try to protect free expression by saying, hey, we only want to take automated actions when the confidence of our models exceeds some baseline level of human performance. This is going to be useful for us because it would be a very different system if we wanted to remove basically anything that smelled like it might be harmful. all the way through to something like 4chan, where you're going to have to twist their arm legally to get them to remove some pretty nasty stuff. Now, during this, what we'll do is we will record this on our whiteboard. And that's a great way to make sure that we're aligned with our interviewer. And then also for us to keep track of this for later. And what I'm writing down here are things like, hey, we only care about text and images. And we've got 1 billion posts a day, and only 1% of them are harmful. You're free to make some assumptions. You can write stuff here. You don't have to ask your interviewer. You can just lay it out there to say, I think Facebook is a pretty big platform. It probably has about 1 billion users. Does that sound about right? And most interviewers are going to go, thumbs up. I want to get to the interesting stuff. Let's talk about ML. The next piece that we're going to build up is our business objective. And I'd mentioned earlier that this is one of those places where senior candidates will differentiate themselves quite heavily. A naive business objective would be, let's remove as much harmful content as possible. And it kind of makes sense. You don't want to have this stuff. But practically, systems make mistakes. And those mistakes have real ramifications for users. So the next level business objective would be, let's remove as much stuff as we can, subject to some sort of guardrail. In this case, we might take a precision guardrail. We had earlier clarified that our interviewer wants us to be 95% confident. And what that allows us to do is to say, well, we're going to try to remove as much as possible, but we want to be right 95% of the time, marginally. This is a much better business objective and will probably get you a pass in the interview. Another level requires that we recognize that all content isn't exactly the same. If we have a piece of pornography and we dump it on the platform and nobody sees it, does anybody care? The answer is probably no. On the other hand, if we dump it on our timeline and it gets shared millions of times and gets billions of views, do we care? Well, yeah, that matters a lot. So what we see here is that actually viewership is really important. So a next level business objective would be something that is aware of views. Maybe we want to minimize the number of views of known harmful content on this site. And what this objective does is it changes the problem a little bit. Now we don't care necessarily about how accurate we are on everything. We care more about being accurate on those things that are going to get lots of views. And that necessarily can change our approach. It also gives us the answer to some other questions that might come later. As an example, when do we run classification? If we want to remove just any piece of content, we need to run that when the post is first created. On the other hand, if we're simply trying to suppress views of known harmful content, well, technically we can be a little bit late as long as we get it before the majority of views are happening. So it really changes the dynamic of this problem. Not all problems will be this straightforward, but the ML objective here is a simple classification problem. We want to determine for a given piece of content at a certain point in time whether it is harmful or not. And that allows us to take an action downstream. With our problem framed, we get an opportunity to move to our high-level design. This is where you're going to take that ML objective and start to sketch out what the system might look like. Now, some candidates at this stage are going to start drawing databases, are going to be analyzing query patterns, and they're treating this a lot like a SWE-level system design problem. In most cases, you don't need to do that. What interviewers are more concerned with is how do the pieces fit together, and then how does your system ultimately act with the world? A lot of ML system design interviews are going to focus on feedback loops and how your actions have ramifications for your data and the system as it evolves over time. And those things aren't clear until you have a sketch of the system itself. Now, my recommendation is to draw some things on your whiteboard at this stage. But don't spend too much time here. I think a lot of candidates will try to make a pristine and perfect diagram when that's really not the intent. We're really just trying to set the stage for our discussion. So for this problem, it's pretty basic. We have posts that are created or viewed. These might be places that you would trigger a classification. We're going to have a classification model. It's going to feed scores into a calibration. And because we had earlier established that we can take action when posts are 95% confident, if it's above 95% confidence, we're going to delete it. And if not, we're going to demote it. Now, this isn't my final design. This is just a starting point. And what this gives me the flexibility to do is as we come up with new requirements or new ideas, I can move things around and work from here. But this should be sufficient for a high-level design, and we'll keep moving. The next part of the interview, we're going to talk about data and features. You can think of this as like data sets and features that might be incorporated into the model. The important thing is we somehow need to go from the raw material towards something that we can train on and use for prediction. Now, the first step is talking about those data sets. And a lot of candidates think about this problem and they think, I'll just use that labeled data. That should be enough. But we earlier mentioned that we only have 50,000 labeled examples. That's not a lot. And so we need to figure out how we can be economical with the data that we're using. And it turns out that there's a lot more than just simple supervised data. This is the easy way to stand out as a candidate in this problem is to think more broadly. For a lot of ML problems, especially ones that are limited in the data that's available, figuring out how you can incorporate and transfer learn and take advantage of other data sets is one of the ways that you make that system better. So if we think about supervised data, we of course have our labeled data set. We want to make note of that. There are a lot of NSFW, not safe for work, data sets that are available online. Now, that's only going to tell us a little bit about photos or videos, but it is going to be useful information that goes beyond what we have with labeled data. It just isn't available at a post level of granularity. So we'll talk about it. The next thing is we might think about how we have some data with partial supervision. As an example, with this problem, users might either react negatively to posts, like hide them, or they might submit reports. They might say, hey, this thing shouldn't belong on the platform. These are going to be really useful signals for us to train our models and can be very interesting with figuring out how we would actually incorporate them. Finally, we should make use of unsupervised data. And this is a very common pattern amongst big companies, is to say, I've got billions of posts. Most of them aren't harmful. Is there anything interesting that I can learn from them that might help me in finding out what content is harmful? As one example here, I can use the comments on a post to tell me whether or not it is harmful or not. If users are commenting gross, that might indicate that this is something that they don't want to see. It could also be that they're just joking with their friends and they say happy birthday and someone says gross. It's not a perfect source of supervision, but there is a good chance that it's going to be correlated. And what your interviewer wants to see as you're discussing some of these data sets is, first of all, that you're creative, that you're thinking not just of the labeled data, but secondly, that you have some hypothesis for how this data is actually going to help to improve your model downstream. So be exhaustive, but also don't spend too much time here. It's very likely that the first few ideas that come to your head are going to be some of the best ones. And spending too much time here will have diminishing returns. With our data sets established and some discussion that will come from it, we're next going to move into the feature engineering part of the discussion. And this is oftentimes a bit of a tar pit for a lot of candidates because there's so much that we can talk about here. The simple reality is, for most systems, there is a nearly infinite number of features that you can engineer. The real challenge is deciding which ones are going to be most important and impactful for your problem and prioritizing those. In some cases, adding additional features will actually make your model worse. With deeper models, this isn't as much of a problem, but it'll definitely affect training and inference time, so it's a worthy consideration. With your feature discussion, the important thing is you start with some hypotheses, and then you start to elaborate on those. And then that you constrain your discussion, that you keep things moving. There is a lot that your interviewer might probe you on, including how features are represented or encoding. I would oftentimes follow their lead on what that looks like. For harmful content, we can think of a crude categorization of features that we might include. And that's actually probably a useful thing to do for almost any problem that you might run into. First, we have the direct content features. These are the most obvious, and poor candidates will oftentimes focus exclusively here. But if we're going to be finding harmful content, we of course need to care about the things that actually make it harmful, the text or the image that's associated with the post. The next thing that we should consider is whether or not there are behaviors that are associated with harmful content. As an example, if people are reacting negatively or they're sharing, maybe with specific captions, we can start to tally these and incorporate them into our prediction. They aren't necessarily required. We don't need to have negative reactions to make an assessment about whether something is harmful. But as we accumulate negative reactions, it might tilt the scale for us. Remember, we're not just making this determination at the post-creation time where we wouldn't have any behavioral features. We're also making this determination later on as posts gain viewership and potentially the decision becomes easier. Now, as we're noting about negative reactions or shares, we're going to want to talk to our interviewer about how we might normalize these things. The worst case scenario would be looking at these features in an unnormalized fashion. That makes it both hard to train, but it also means that there is some skew. If a post has millions of views, there's a very high likelihood that some of those reactions will be negative. If, on the other hand, a post had 50 views and 25 of them were negative, that's more telling. So a great way to deal with this is to incorporate ratios into the encoding of these features. Finally, our creator is going to tell us a lot about the likelihood that they are posting harmful content. If we have our grandma who's been publishing cat pictures for the last 5 years, we don't expect, unless her account is compromised, for her to start publishing graphic violence, as an example. On the other hand, if I have a brand new account, I have no history of them, they might be more likely than not. So how can we deal with the creator? Well, there's kind of two ways for us to look at this. One is we want some sort of representation of that user that tells us ritually, who is this person and what kind of things are they likely to post in the past? Having some sort of embedding of our user is a really great way for us to incorporate this information in our classification. But we also want something that's going to be a bit more fast moving, that's going to respond to behavioral changes. And so being able to say and look at the last N postings and how many of them are harmful content is a useful way to distill out the most important aspects of that user's history. In this case, if they posted lots of content in the past, well, they're probably going to post it a lot in the future. I also might talk with my interviewer about the age of the account and other compromise or spam-oriented metrics. Just inside baseball, these are disproportionately the users who are going to violate the rules because they don't care about the account. But at that point, I've talked about some really interesting pieces. I've got the multimodal classification problem. I have a bunch of dense features that I'm going to be incorporating. And on these user embeddings, I've got to figure out how I'm going to train those embeddings to be useful for my problem of classifying harmful content. So there's lots to talk about here. At this stage, I'm putting down my pencil and moving on to the next section. I want to make sure that I'm not spending so much time in the feature engineering discussion that I burn all my time that I would be using for other topics. The next part of our interview is the modeling section. And this is oftentimes a key, load-bearing determining point for a lot of interviewers. And partly because many candidates get in over their skis. They either kind of hand wave about approaches that they're not familiar with, or maybe they make some mistakes because they're not really clear themselves. It is important that you understand modeling for the applied ML interviews, and your interviewer is frequently going to use this section as a determinant for whether you're going to have some depth here. Especially for senior and staff level candidates, this is a very important section to get right. Now, I see about 3 approaches. The first is a classical approach that basically looks like us taking 3 different classifiers and then choosing the highest score amongst them to make a decision. So I'll take a text classifier. I might use a BERT style model, an image classifier. Maybe I'll use a CNN, and then maybe I'll use a logistic regression for my behavioral classifier. Each of these outputs a score. I take the max of that score, and then I threshold it and decide whether or not it's harmful or benign. The reason that candidates will bring this up is 2 things. One is it's very interpretable. I can figure out whether it was harmful or benign based on the modality just by looking at the scores. And then the second thing that they will bring up is it is very high performance, which is absolutely true. Important. We need to classify billions of posts, so we need this system to move relatively quickly. The problem with this is it's far from optimal, And in a lot of cases, we can solve for both the interpretability and the performance in other ways. So this would typically not be a passing solution for this interview. The next level that candidates will oftentimes come to is to use embeddings. So again, we'll use pre-trained models at the top here. And then instead of taking the maximum score, we're going to feed these into a multi-layer perceptron. And what this allows us to do is learn interactions between modalities, which is really important because it might be that the text doesn't actually mean anything without the image. Now, MLPs aren't particularly good at learning multimodal interactions, but it theoretically could work here. Candidates will need to answer questions around how some of these embeddings are incorporated. As an example, if I have multiple images in a post, what can I do? And a really common solution here is either to take the average of the embeddings or take the max, or sometimes take both of those and incorporate them into the model. This is not a terrible solution, and in some cases, it will satisfy. We will probably want to fine-tune these models at some level, so interviewers might go into detail about that, and then we'll want to figure out how we can train them from scratch. One of the bigger problems that we run into with this MLP, with these really wide inputs, is that we don't have enough data to truly train this from end to end. 50,000 labeled examples is just not enough. So we need to be able to address that problem. I'll talk about some solutions for that in just a second, but I want to bring up the last architecture here, which is using a modern transformer-based multimodal architecture. Now, there's a bunch of papers that are out there, and I have some of them linked in the guide. But the key thing here is we can represent images as a sequence of patches. We can basically take a grid and decompose them. And then those images can be represented just like tokens from text in a transformer. And what that transformer will do is it can jointly learn to attend to either the text or the images in this task. And it can learn any sort of long-term relationships between them. Again, theoretically, the MLP has this information, but in practice, it very rarely does this. And what we can also do is fuse in our dense features at the last moment before we ultimately make our classification. Now, there's a bunch of reasons why this approach sounds pretty good. One is that we're using a modern transformer-based architecture. It's hard to ignore how effective transformers have been across machine learning, and it's always a bit surprising when candidates come in without a transformer-based solution, so this is an easy way for you to take advantage of it. The other thing is that these dense behavioral features change as the post is interacting with the world, whereas the images and text very rarely change. What this means is that we can potentially cache the embeddings that are produced here. And then if we want to run reclassifications, for instance, later on as the post is viewed multiple times, or maybe after it's been reported, we can do so pretty cheaply. We get kind of the same benefits that we had earlier. So interviewers are going to want to understand a bit about the mechanics, like how does this transformer work and what's the sequence, and do we need positional encodings to represent the relationship between images or their ordering? But in general, we've got a pretty good solution here. Now, I talked earlier about the challenge that we have around this problem is that we just don't have enough data to train. And in fact, this classification head of having a single harmful or benign task is probably insufficient. But fortunately, earlier, we talked about other data sources that we can use for supervision. So as one example, we can use user reports. And this presents a really cool opportunity to basically 1,000x the data that's available. We might only have 50,000 examples that our expert reviewers have labeled positive or negative, but the proportion of reports, and we probably want to normalize this by views, that have come in exist on millions of pieces of content. And so what this model will learn, if we basically take a multitask objective, is what posts are most likely to produce reports. And our assumption is that that correlates with the harmful or benign determination that we have. This is one of the primary advantages of multitask learning, is that if our tasks have some correlation, our model is able to learn that correlation and exploit it. And in this case, what we do is we're able to multiply the amount of data that's available, and we get this really useful additional head on the model that tells us whether a user is likely to report. It might be really interesting for us in production to go and look at those posts that are predicted as harmful, but are predicted as unlikely to be reported. Those are going to be really interesting. Or maybe the reverse, posts that are really likely to be reported, but aren't actually, according to our standards, as harmful, might be a great diagnostic tool. We can extend the multitask learning to incorporate new tasks as well. Like we could, for instance, add a task that tells us whether or not it was nudity. And what this will do is it'll give us some idea of whether or why the model is telling us that this is harmful. It's less useful for us to say, hey, the model output a score of 0.9 harmful for this. It's more useful for us to say it's 0.9 harmful and it's 0.89 nudity. Now we know why the model is thinking that this is likely to be harmful. So what we've done here is we basically solved part of the interpretability problem that we introduced earlier. And we also have solved part of the data scarcity issues that we alluded to in the data discussion. There are a few things that interviewers occasionally will dive into here. The first is the loss function. We're probably going to use binary cross entropy here. It's a multitask loss, so we are going to need hyperparameters which govern, how these sum together. We will, of course, favor our primary task as harmful or benign, because it doesn't matter if we get really good at determining whether it's nudity or not when the ultimate task is harmful or benign. We might also add a term here for how much views an item gets. And the idea would be to get the model to focus more on those things that are going to get lots of views. And this can be a bit precarious because views in particular are power law distributed. You have some things that have hundreds of millions of views and others with zero. So we might want to employ some sort of transformation, maybe a log, so that way we can ensure that we don't have singular examples which are completely dominating our entire training run. The next thing that frequently comes up is discussion of early or late fusion. This is really common in multimodal questions. And in this case, what we're doing is we're using early fusion for our text and images, and we're using late fusion for our dense behavioral features. There is, of course, a variant where we encode these dense behavioral features in with our transformers, so that way our text and images can also interact with it. But in this case, we don't really want to do that because we're making an optimization for inference time. There's also a real question around how much these text and images can be cached. In production systems, you typically are going to have these embeddings produced once. You might have one team producing, image representations that are consumed by dozens of systems, maybe customer support, maybe content moderation, maybe personalization and ranking. And so that will play into the determination as to where you're going to draw the line and where you'll ultimately freeze parameters in your model. The final discussion that you might encounter here is how you deal with class imbalance. And for this problem, the simple answer is we will probably balance the data set. So ideally, you would want to make sure that your positives are upweighted in your sampling. So you're not having mini batches that contain no positives. Those aren't particularly helpful. And then you will also potentially include some additional terms in your loss function. You probably won't be able to get away with exclusively including terms in your loss function because the class imbalance is so acute for this problem. You'll need to do a little bit of both. Okay, so now we've got a model in place, and that's part of the description of the overall system. But we're going to move to discussing inference and evaluation. Inference time concerns are oftentimes rooted in scaling, but there's also some behavioral questions like how do these actions actually take place? And so it's usually worth elaborating a bit on all the pieces that are involved there. Now, I kind of shot myself in the foot. I've proposed a model that is very parameter rich, which is going to be very expensive to do inference on and probably going to require specialized GPU hardware. So before finance blows up on this particular solution, we need to figure out some way to optimize. Now, the most straightforward way for us to reduce inference costs is to employ a multi-stage architecture. If you're familiar with recommendation systems, this should be very familiar to you. The idea here is that we probably don't need to run our model on the vast majority of content. Grandma's video about a kitten, the post by, some person that's just discussing the weather, these probably aren't going to be harmful in almost any circumstances. And so what we really want to do is try to figure out, can we build a lightweight model that can run very quickly and then tell us whether or not our heavyweight model needs to run? So here I've kind of diagrammed that out. I've added a lightweight classification model into the space in my high-level design diagram, and then basically indicated that we have some tunable threshold here. Now, the lightweight model needs to probably use less features because we don't want to have to pull all the features, and we aren't going to have nearly as much expressive power. So what can we do here? Really common options are to use something like Light GBM or XGBoost. CPU-driven tree-based models can be very popular. Another solution here would be to use our MLP-based approach. The accuracy isn't all that great. That's fine though, because we only want to approximate what we're going to see from the output of the larger model. And so the way that we might train this lightweight classification model is in a teacher-student or kind of a distillation fashion, where the lightweight model is trying to predict the output of the heavyweight model. And what that allows us to ensure is that the lightweight model is never going to, or not never, it's less likely to pass things that the heavyweight model is going to say, no, that's obviously not violating. It's going to try to approximate it. And then what we'll do is we will take some cut line. We might decide that we can only run our heavyweight model on 10% of content or 1% of content. And we will choose a threshold that the lightweight model will basically pass all content beneath it, and the heavyweight model will only look at the top scoring content. This inherently is going to change how the system operates in production. The heavyweight model is not going to look at obviously non-violating content very often. So in production, we're going to need some way to sample from this lightweight classifier so that both we get scores from the larger model that we can use in evaluation, but also we can get an indication as to whether we're missing things. The worst case scenario is the lightweight model is telling something that is actually harmful, no, and in those cases, it's going to hurt the recall of our system. The second thing that we're going to want to talk about in inference is just about this calibration. When our model makes predictions, it's going to output a raw score between 0 and 1. And that score doesn't necessarily correspond to a 95% confidence level or even something that humans would label that. And so we need a simpler way to go and take that score and translate it into something that's, more useful for us, which would be like a probability. The calibration model, it's very common to use something called isotonic regression, although there are a lot of options here. And essentially, we're going to have reviewers label things at each score band, and then we're going to use that to correct the scores. We're basically going to learn a transformation that will take those raw scores and turn them into calibrated scores. And those are going to be the things that we will use to delete or demote posts. Nighttime. I overwrote the recording. Anyway, for evaluations, what we're trying to do is figure out for each incremental release, each new model, what is the change in our business impact? There's two ways to look at this. We can do online evaluations, which are usually more expensive, and we can do offline evaluations, which we expect to be cheap and fast. Online evaluations for human-labeled problems like this one tend to be very expensive. For this problem in particular, if we randomly select content, we have to label 100 examples before we find one example of harmful content. So in some sense, we're going to be spending a lot of money on labeling. There is a good point to say how we can be label efficient. Basically, how we can make sure that things are better in a way that doesn't require much labeling. One is our model is making a decision. It is either deleting the content or it isn't. And if we are comparing two models, if those two models agree, either A, they both want to delete, or B, they both want to ignore or believe the content is benign, there can be no difference in performance for those decisions. The only difference between them comes from when the two classifiers disagree. So our A/B test is going to be measuring those cases where the models are at odds with one another. The second thing that we can do is we can use importance sampling. I'm not going to be able to give you a primer on importance sampling here, but the basic idea is that we're going to use stratified sampling using a classifier score. We'll spend more time labeling those things that might be harmful. With our offline evaluation, we want these evaluations to be cheap and faithful to what we would see in online. The point of both online and offline evaluations are those business metrics up at the top. We care most about preventing views and keeping precision guardrails. So our offline needs to correlate with that. For this particular problem, we are probably going to use something like PRAUC. A lot of candidates think that we might want to use ROC-AUC for this problem because it's a pretty traditional classifier metric, but it's not actually appropriate given acute class imbalances. ROC-AUC will saturate very quickly, and it's not going to tell you a lot about the performance of the classifier in this case. PRAUC is the area under the curve of the precision recall curve. This is basically the trade-off between making a mistake in one direction or another. The other metric that we might want to look at is the recall at precision 95. 95 is special here. Remember, in our requirements, we're going to be taking action when we're 95% confident. When the precision is 95, that's when we are 95% confident. And what we're trying to measure is the recall, basically how many instances of harmful content did we find. Another way of saying this is what proportion of harmful content in the data set that I have was I able to take action on in kind of a simulated environment that I would run in a Jupyter notebook. Now, all of these offline metrics are going to be tainted. They're going to be tainted by how the data was collected, and that's either because some human somewhere is choosing examples, in which case there will be their bias, or because there was another classifier running in production that chose these examples to be labeled. Another thing that interviewers will sometimes go into, although very infrequently in great depth, is bias evaluations. What we want to do is make sure that our model is not making mistakes disproportionately for specific groups. So a typical way to do this is just to look at the error rates of various groups and make sure that we are not over or under actioning in those groups. These don't have to be demographic groups. They can also be user-related groups. So like we might want to look at new users versus old users, because it's not uncommon for systems like this to penalize new users. And that can set off this sort of vicious cycle where we end up hurting the new users who never make it onto the platform. The last stage of our interview is where we're going to do deep dives. And these are going to be things that we maybe had deferred earlier in the session and basically said, I'm going to get back to that a little bit later. Or these might be places where our interviewer throws us a curveball and says, hey, how do you solve this problem? Some example deep dives that might be relevant for this problem are we brought up embeddings for users earlier. We thought that would be useful information for our model, particularly the creator's embeddings. So one question might be, how do we train those embeddings? There's a bunch of different options here. And I think the kind of most naive option would be simply having the creator as a categorical input to our model during training. And the idea would be we would jointly learn the embeddings for each user together with the task of trying to figure out whether it's harmful or not. But I don't think this is a very good approach, in part because we already have a problem of lack of data. We're not going to learn very useful embeddings for users, and in more likelihood, what we're going to do is overfit to users. We're basically going to be able to find users in the past who have created lots of harmful content, and the model will memorize those users. And that will make it very brittle. It's not going to be very predictive into the future. So the better approach here is probably to use some sort of auxiliary model that learns a representation of users that's useful for our task. One popular approach here is to use graph neural networks in order to train this. So if you imagine we have a social graph at Facebook, which hopefully is useful. Each of these users might be friends with one another. They might belong to different groups. And our graph neural network's responsibility is to basically predict the edges that exist between nodes. There are two types of models that we can employ here. One would be a transductive graph model. That would be We have all of the users and groups during model training time, and we're going to cold start and train their embeddings from scratch. Transductive models are really nice because they can learn very interesting relationships between all of the different nodes in the graph, but they're static. We have to take a snapshot of our data at that time, and then those embeddings are going to be based on that graph as it existed at that moment. This can be a problem because if we need to retrain, then those embeddings are going to shift around. And if we have new embeddings that we feed into our model that was trained on the old embeddings, we're going to get pretty garbage results. But there are ways that we might be able to fix this for a period of time and orchestrate retraining of our model and make use of it. Another way that we can do is we can train a graph neural network using an inductive approach like GraphSage. And the idea here is we will take features of the users and the nodes and the edges as a way to go and learn their embeddings. And what this allows us to do is instead of having a lookup table where for a given user we can find their embeddings, instead we'll go grab the features of that user, potentially some of the edges that exist at that moment, oftentimes randomly sampled. And then we'll feed that into our model to produce an embedding at that moment. I think that is a more clean approach in this particular problem, but it still has some of the problems. If that model itself is retrained, we'll need to do some sort of versioning dance in order to make this work. Another deep dive that's very common for this problem is dealing with adversarial creators. So imagine I'm a user and I really want to do terrorism on Facebook. If I create a post and I notice that it gets taken down, I'm going to change that post a little bit. So that way, next time it doesn't get taken down. Why does this happen? Well, oftentimes models fail to generalize in the adversarial domain. People are going to make shifts. So like one example might be instead of writing gun, I might write G-O-N. And in this case, G-O-N isn't actually a word. It would be out of vocabulary in my text model and probably mapped to an embedding that's not all that useful. So in that case, my model is going to produce a garbage result, and I'm not going to be able to even retrain in a way that's going to produce a meaningful improvement. There are lots of ways of dealing with adversarial problems. Some of them are coming up with, for instance, tokenizers that are at a lower level. So instead of having words in our tokenizer, maybe we do a byte level tokenization. We can also have models that are trained with the objective of being robust to some of these perturbations. We can augment our data set, so that way we take all of our positive examples and disturb them in little ways that keep the violation, keep it harmful, but ultimately make it difficult for our model to come up with a confident decision. There's a bunch more that we could go into here, but ultimately you're going to have somewhat limited time to go into deep dives because you'll have spent most of it, hopefully, on the earlier sections of this interview. Okay, wow, we covered a lot of ground. So I want to stop here and summarize a bit about what interviewers are looking for at each level. And then I want to briefly summarize the different stages of this interview and things that you might want to keep in mind for other ML design interviews. Generally speaking, for mid-level engineers with this problem, what interviewers are expecting is that you can reasonably independently work through a solution to the problem, that you've got a good handle on modeling and feature engineering, that you have some idea about how evaluations might be conducted, and that you're starting to show some emergent depth in the problem. Maybe you have an approach that's more interesting or more optimal. They aren't expecting that you have the answer that I've written here, by no means. A senior candidate is going to have substantially more depth. In a ML system design interview, it's not always the case that you've been working on classification problems. You might have been working on rec systems or forecasting or something else. But they are expecting that you have a lot of generalizable knowledge that you can apply in new domains. And so they're not only expecting you to be able to work through the end-to-end life cycle, but they're expecting you to bring nuggets to the table about things that work, things that don't, and research that you've read. Those types of things are going to be really important to nailing the interview. At the staff level, this is where interviewers are expecting you to bring some novel insights to the problem. Not only are they expecting a pretty wide breadth of experience, but they're also looking for those small ways that you can level up the entire ML execution. I mentioned the business objective at the beginning of this problem. That's oftentimes the first sign that I'll see from candidates in interviews that they are at the staff level when they think really deeply about that question and they come up with some clever formulation that gets at the heart of what the business is trying to do with this system. Their modeling depth is going to be substantially stronger. And with staff level candidates, they're usually bringing some experience that as an interviewer, I'm not familiar with. And what I want to see in those cases is that they are able to explain those things to me in a capable way that levels up how I think about this problem into the future. If that sounds like an insurmountable bar, it is absolutely not. You'll learn a lot as you conduct interviews, but it is important that staff level candidates are showing kind of the difference between them and senior candidates. And those are two dimensions on which that actually happens. Now, just as a recap, we talked a lot about the framework at the beginning, but I want to just remind you how we worked through this problem. We started by asking a lot of questions. Our goal was to develop clarity in our mind and also to start to set up the problem. We want to spend time thinking about the business objective so we can choose a good ML objective that aligns with the maximum impact we hope to realize with the problem. Our high-level design is an early sketch of our problem that tells us how the pieces fit together, and it's a communication tool. Your interviewer is not assessing you on your whiteboarding skills, so don't overfixate on it. With our data discussion, we want to show that we can make use of creative new data sources, but we want to be careful that we're not spending so much time in this phase and not really bringing any novel insights to the table. Bring some hypotheses about what's going to be most important, enumerate data that aligns with those hypotheses, and keep moving. It's really important in the feature discussion to not get lost in it, but definitely don't hold yourself back. It is a shame when candidates think about this problem as only using text and images as an example. When it comes to modeling, remember that transformers are transforming machine learning, and they are applicable in a wide variety of situations. The more modeling acumen you can show, the more likely you are to nail the interview. So be careful about approaches that are big boxes. Those are typically less appropriate for applied ML interviews and are somewhat okay for the ML infra, where generally speaking, interviewers aren't expecting as much modeling expertise. In inference and evaluation, you want to think about your system from end to end. Think about feedback loops that might exist in the system. Think about the consequences of any actions that it might be taking, and think about scaling. For evaluation, online and offline evaluation is both important to cover. And there's a bunch, we've actually written a guide on the site that talks about typical evaluations for various problems, from rec systems and ranking systems to classification problems. Definitely go check it out. Deep dives is where you're going to reserve some time to go back to those things that you called attention to earlier that you maybe didn't have time for, and give your interviewer a chance to ask you questions and then try to test your knowledge. It's uncomfortable, but a lot of candidates really just try to crowd out the time and try to always be talking. But the reality is it's good to be able to get to a complete solution, to give them some hints and say, hey, these are some things I'd like to touch on, but also give them a chance to say, no, I'm really interested about this or concerned with that. Let's go talk about that more. That gives you a chance to respond to those things. Whereas if you crowd out all of the time, then your interviewer is going to be left with whatever assumption that they started with. And a lot of interviewers aren't very charitable, which I think is very unfortunate, but it's the reality and it's important that you know it. We've got a lot more material on the website and I'm hoping to create more videos coming up. I would love your feedback and comments, so let us know how we did and any ways that we can improve. And then until next time, I'm Stefan and thanks for watching.